we talk about imaging, Macintosh System Software, we're really talking about acquiring images, displaying them on the screen, printing them, printing documents, and fonts. Fonts are a core technology to documents, and that's part of our imaging group. Today I'm going to make a couple market observations, some trends that we've noticed in the business place. I'm going to move into our technology agenda for imaging software and wind up with a demonstration that I think you'll find very interesting. What I want you all to learn today, what I'm here to talk to you about, is a new imaging architecture. This is new. We haven't talked about this in a public forum before, and my goal is for you to understand what the new imaging architecture is all about and why we're doing it. First of all, and this relates to what Rick was talking about earlier this morning, we've noticed that our customers are now worldwide. Our user base is a worldwide user base. This has implications in the imaging group. Also, from a developer perspective, many of our developers are actually leading system software. So, for example, in the area of 3D or in high-end desktop publishing, the developers are quite a bit further out from where system software is. System software is focused on other things. So there are opportunities for us to make improvements. And something that affects both users and developers is color. Color is just too difficult today. It used to be too expensive, unaffordable, but the cost of printers is coming down. The cost of color printers is coming down, but ease of use is not following that trend. To sell software worldwide, you need to localize. And by localize here, I mean translate strings. That'll take your software or your system software into Europe, other one-byte Roman countries, but it won't work in a place like Japan where you really need fonts. It does no good to get a Japanese string if you can't display Japanese text. Once you get the fonts in place, though, system software really needs to support what we call line layout or text layout. You can imagine what would happen if a computer company outside the United States came into the United States and tried to sell a computer system that had only one font, uppercase characters, and for the most part it worked right to left, but every now and then a word would come out from right to left. We wouldn't buy that, and yet many of us, many PC companies, are trying to sell systems like that overseas. Macintosh is poised to be in position to sell a high-quality, native system around the world. In the area of color, the real goal is color WYSIWYG, so that when a user sees or creates red on their screen, they get red on their paper, not brown, not violet, not just black or some weird pattern. To do that, system software must work in multiple color spaces. So users have notions of color in their mind. In the system software, it needs to be translated into red, green, blue values, for example, to display on a screen. To display on a printer, though, you need to work in CMYK space, or cyan, many printers at least, cyan, magenta, yellow, and black. And there are other classes of devices out there that don't work with those colors, work with even other color spaces. When applications get ahead of system software, innovation occurs. That's good. We like innovation. But it does lead to some implications. Applications, we've observed, keep inventing common code over, text layout here, text layout here, text layout here. The same is true for hit testing or other pieces of the user interface. That's basically redundant. When you have redundancy, you have inefficiency. From a system software perspective, you have an inefficient system since the common code is being reinvented and living in the system in multiple places. From a developer's perspective, they keep reinventing computer science, as somebody said earlier. There are many opportunities for us to bring this common code down into the base. This will increase user consistency and ease of use, since that software will live in exactly one place. Well, the imaging team went off, put these facts, many others, into our minds, into our food processors, and came up with an imaging strategy, a technology agenda. This agenda has been in place for about 3 years now, and we're talking to you for the first time about it. Obviously, we need to support QuickDraw. QuickDraw is not dead. There are over 6 or 7 million installed happy QuickDraw users out there now. So we'll be making enhancements to QuickDraw on a selective basis. But the real point, and where the spotlight really should shift, is to our new imaging architecture. This is something that's been underway. You've heard about it, bits and pieces of it in the past. We're going to put the whole package together today. And then, once that's in place, we're going to be delivering incremental technologies, what I'm calling themes. Themes, for example, such as 3D, digital photography, animation. And those will build on our new imaging architecture. So we talked about QuickDraw. You'll see enhancements to QuickDraw. The world-ready release that will be coming out later this year incorporates a number of enhancements to QuickDraw and to text processing, obviously to handle the 2-byte world in Asia. We'll also be making selective performance enhancements, and you'll see our first steps at color management coming out in a QuickDraw base later on this year. We'll be getting our feet wet with QuickDraw, but the emphasis in color will be in the new imaging architecture. The goals that we had for this architecture were first and foremost to enhance the user experience. We can do this directly in the area of printing, where we can add things such as direct manipulation to the screen. So you just drag documents to the printers. But there's really much more than that trivial example. We want to bring color publishing to people. We want to have that worldwide system. We want to provide text and fonts around the world. We have a goal of 2 fonts in every country. Those will be 2 type fonts or type 1 fonts. We want to make sure users have fonts so that we can sell systems there. And we need to support new devices. As we talk about consumer products, you're typically connecting low-cost dot matrix type printers. At the upper end, high-end photo typesetters. So we need an architecture that was scalable from these low-end devices, consumer products, on up through high-end needs in desktop publishing. And we want to bring a richer developer experience to our developers. So they've been asking us for features for many years, and we're responding. We're going to meet their needs and in many cases exceed them, as you'll see in a moment. Now, many of you heard about a new printing architecture back in 1989 at the Worldwide Developers Conference, and some of you might be wondering, where did it go? You also heard about line layout or text layout capabilities. A line layout manager was demonstrated. Where did that go? We took these technologies and decided to integrate them a little more tightly and also build on a brand new graphics foundation. As we listened to developers, as we listened to customers, we realized that QuickDraw was the best, but it wasn't going to be good enough to get us through the 90s, through the next decade. And so we've been working on a new graphics foundation as part of the total new imaging architecture. And now I'm going to move into a demonstration of the graphics portion of the system. I want you to realize and keep in your mind that there's quite a bit more to the new imaging architecture than just graphics. There's a whole new realm of printing. There are new additions and extensions to TrueType. There's Type 1 integration. I'll touch on some of those at the end, but we'll really be encouraged to come back to these forums and we'll roll out the rest of these technologies at a subsequent date. What we're looking at here is a sample application created in the new imaging architecture. We call this the slideshow. It was written by our engineering team. We use it to demonstrate to demonstrate the software. Primarily, the new imaging architecture is object-based. I don't want to say object-oriented because I think that has a lot of baggage associated with it. What we're talking about is the ability of developers to create objects in their application, objects such as lines, curves, rectangles, arbitrary polygons, collections of these shapes, so we call paths. Text is a first-class object in the system, so we support text in new and interesting ways. Bitmaps, as you see, we can do rotation. And then we have a container object. We call it a picture that puts these things all together. This is different from QuickDraw, which sort of had a move to, and no notion of objects. Now we talk about creating objects, and once you have a series of objects, you can start applying different things such as styles. Polygons. Sorry, John. So polygons, for example, can be open or closed. They can have multiple fills. And we can do animation with our polygons. This is a single polygon. It has approximately 180 contours to it. It's an open polygon. And what we're doing is saying draw polygon, rotate, draw. It's a very simple set of code to create this. In QuickDraw, it'd be very difficult to do this sort of thing. All right, now. Once you've created some shapes in your application, you can apply transforms to them. We'll talk about that. Attributes such as and styles, and you can also apply inks, which is our word for color. What we mean when we say color, when we talk about light blue, most of us have some notion in our head of something between dark blue and white. But on a screen, you've got to translate that into RGB values, red, green, and blue values. On a printer, CMYK. Once you need output, you've got a color match to the device. So we have a very rich color matching system built into the new imaging architecture. What you see here is a picture of a car. Users created this. They want to print it to their QMS printer. To maintain the fidelity, though, we need to send a different set of data to the printer. The system automatically knows how to read something that we call device profiles, modify the output on the way to the device, and send something entirely different to get the right result, so that users can have the what you see is what you get experience. This is a little example that somebody put together just to show how color is fundamental in the system. What we're doing is simulating the knobs on your color TV. So we can play a lot of games with special effects, but more importantly, color is fundamental. It's built in, modifying tints, brightness, saturation, and so on. Okay, we'll move on. Another aspect of displaying is dithering. When you have a high bit depth picture with a low bit depth device, you typically, without any extra processing, would get something that looks like this. Notice the gradations between the tones. It's sort of very quantum steps as we make use of the limited number of colors available in the system. We're simulating an 8-bit display right here. Dithering's built into the system so that the application developer can easily say, smooth this, dither this. And you'll see on the, if you can't see it on the overheads downstairs, you'll be able to see how smooth the continuous scales go. If you're on even a lower quality device, such as a black and white printer, you need to move into the realm of half-toning. The system has a very rich half-toning model built in. We can vary the dot size, the angles. Half-toning will work with color. And it's also useful for, or fun for special effects, which somebody put here. Now, when you go to print to color devices, most color devices don't print all of the inks, all of the colors at the same time. You need to make several passes over the page. It's called color separation. You need to take colors apart, put them back together. So what we've done here is taken a picture apart into 4 components: cyan, magenta, yellow, and black. And we're going to simulate what happens in a printer as those get put back together. So you'll see the black added in, then the yellow, then the magenta, then the cyan, and we'll get the green frog. So the system fundamentally knows how to take color apart, put color back together. So we really expect a lot of developers to embrace color. We expect users to be able to experience color in new ways in their input and their output. I talked about applying transforms to objects. The new imaging architecture includes the standard transforms such as rotation, skewing, and scaling. We have a matrix there that does those things. We also introduce a new concept. Most systems don't have clipping. Clipping lets you take one shape and constrain it to another shape. So here we've constrained the red rectangle to a blue rectangle as we rotate the red rectangle. But that works with arbitrary shapes as well. The interface is very orthogonal. That means you can apply any operation to any object. And since text is just another object or another first-class shape in the system, you can do the same thing with text that you can do with other shapes. We talked about text earlier. The real goal here is better typographic quality text on every system in the United States as well as around the world. Now, in many countries, some of the features that we would consider bells and whistles, such as contextual forms, changing characters depending on where their position is, and you can see an example here with the trailing E. If it's at the end, it looks different than when it's in the middle of a word. These sorts of features are required in other languages. Likewise for ligatures. Most of us have heard of the FI ligature, where you take 2 characters, and if they're next to each other, you turn them into one new character. In some languages, that's required, and for readability purposes. We won't go into all of these right now, but there is a full positioning, tracking, and kerning model in the system as well. Interaction is very important, especially in the area of text. What we've done is extended TrueType to include new information about the fonts, about the characters. So, for example, the angle of inclination in an italic font, whether or not character streams running from left to right or right to left, and you'll see that working here as the entire line is selected at the end. And of course, because of the orthogonality that I mentioned, this all works whether or not the text is rotated, skewed, or scaled. And the application here didn't have to change as we rotated, scaled, and skewed these things. It was the same code, and at the end we applied the matrix to make the effect happen. So it's very easy to code these things for developers, translating into direct user benefit as this sort of interaction will become commonplace on Macintosh and not something special to a very few applications where developers have done a lot of work. Lastly, I want to talk about user control. As the fonts get more intelligent, as we put more information into the fonts about how they're going to be laid out, we need to have overrides. So, for example, we give complete control over the orientation of text. Japanese would like to run vertically, but we give orientation control in terms of the English that's embedded in the middle. So the developer or the user can decide how they want things to appear. Translating some of these user controls into something we might understand here, we've added information to the fonts about superscript, subscript positioning. So as a user types in, the formulas can automatically appear. And actually, in many cases, you've got to turn these features off. We're going to raise the bar in terms of text processing. The effects that you kind of take for granted will happen automatically in the system. You've got to turn things off to get around the defaults. So now, the new imaging architecture is fundamentally a 2D system, but we will be including what we call a camera library so that you can create quite a few 3D effects. This is called flyby, and as we move the mouse, you can zoom in and out and change the angle of the viewing. I'd like to point out that the flyby is being clipped to this window just automatically as part of the graphics system. It's also being scaled and clipped in the smaller view. In fact, this entire slideshow is one big picture that we just keep zooming in and out of to display different things. Making use of the hit testing, for example, you can, well, we won't push it here. Another interesting, it's alpha. I talked a little about hit testing and the geometry notion and clipping. What this means is we can detect whenever two polygons bump into each other or intersect. So we can envision an entire new realm of space war games here with something along these lines. And we've defied the law of gravity in physics to keep the balls from getting stuck in the middle. John will play with this for an hour. I got to keep them moving. And lastly, something that I call the intergalactic particle separator. This is again a single polygon. We're varying the line length based on velocity, and we're just redrawing it over and over again, varying the color a little bit as we go. We envision a whole new class of screensavers with this technology. All right. I don't want to get you totally focused on graphics, although clearly there's a lot happening there. We also have a new printing architecture. One of the first goals here was a new and improved user interface. So, for example, we're going to renovate how people think about page setup. Today, page setup's kind of targeted towards printers. If you're like me, you've experienced many times, you take a floppy from one place to another, and it says, warning, the printer's changed, and you don't know what to do. Reformat. It's scary at best, confusing at least. We want users to start thinking about the paper, the size of the paper they're printing on. So page setup will mean that. Set this up for an 8.5 by 10-inch paper with such and so margins. The printing architecture will figure out how to print that once it's targeted to a specific printer. So if we have to scale or tile or do something along those lines, we'll do it. And if we can't figure out the best thing for the user, we'll ask you interactively, do you want this shrunken? Do you want it expanded? Do you want it tiled? And how do you want it tiled? We're also doing a lot more work in the area of print viewing. So we have a print viewer and status from the printers. So as we add direct manipulation to the interface, you'll be able to double-click these printers on your desktop and see what's going on. And many times you see the green light flashing. You're not sure what's happening. Now we'll know. You'll be able to see what the printer's doing. It's important to realize that we are supporting a broad variety of output devices. Built into the imaging system and fundamental to the imaging system is support for PostScript. PostScript level 2. We're building that into the imaging architecture. The application interface is not display PostScript, but we will support PostScript devices intrinsically as part of the system. We also will, of course, support the generic QuickDraw printers, what most of us know as QuickDraw printers, generic raster devices. We're adding a new class of device, plotters, which will be very exciting for certain application developers. And this is an open architecture, especially in the area of printing. We have a layered approach. Third parties can add extensions or can add value at different portions, different places in the system. It'll be extremely easy to write drivers, and our early seeding has shown that we've had drivers be created in a matter of days, and currently it takes years to do a print driver because the system is building in a lot of the technology. Driver writers can then concentrate on differentiating their printer. So if there's a special feature on their printer, they'll be able to take advantage of it in the system. An example of a special feature would be multiple input bins. So you can tell the system letters in the top bin, 8.5 by 10 paper in the middle bin, and something else in the third bin. And I'd be remiss if I left out fonts. Apple is committed to incorporating Type 1 fonts into system software, and in particular today into the imaging architecture. So we're working very closely with the Adobe engineers. My team, their team are meeting weekly to get Type 1 integrated. Of course, we're also moving forward with TrueType. We're adding a capability called algorithmic fonts, sort of mirrors multiple master technology. And the goal really here with Adobe is to create a common API so that both multiple master technology and whatever TrueType's doing can live under one interface for developers and for end users so that users don't have to worry about which font format their fonts are in. We want to simplify this for users, not make it more complicated, so that they can get on with their business of creating documents. We'll be embedding bitmaps. So today, fonts can live in one of several different files. We want to coalesce that so that one icon contains the font, period, not 2 or 3 or whatever it takes now. Partial font loading is especially important overseas, where it's unreasonable to have a 10 megabyte system file to hold a kanji font. So we have some different ideas here. We'll load sort of an active character set, and we call that partial font loading. And lastly, for users and for developers, some guidelines and tools regarding styles and font families and how the font menu and sizes can work. Because right now, people are taking advantage of different technologies and to tailor their applications. And we need to come back on board with consistency. And working with Adobe, we can do a number of things to simplify the life for everybody. The question in your mind might be, well, gee, when do I get all this stuff, and how's it going to show up? Currently, we're in a pre-alpha state. This week, we'll be entering our alpha verification. We're seeding a small, select group of developers. We have one developer, Adobe, downstairs. They've been seeded, and they've done some very interesting work. This will be an extension to System 7, along the lines of Rick's talk earlier, a modular, modular extension. It's important for you all to realize that this coexists with QuickDraw. This does not remove QuickDraw from the system. QuickDraw is still there. It's still in the ROM. And application developers can they can do nothing, or they can incrementally add features from the new imaging architecture. So if they're interested in color, they can do some of those color things. If they want to get into the area of polygons or curves that they might not have the support that they would like, they can adopt those. And we've watched developers incrementally add these technologies. You can call QuickDraw, you can call the new imaging architecture. The two can come together in the same window. We've done a lot of work to maintain a very simple migration path for developers so that they can choose how much they want to dive in, how much they want to get involved with this stuff. And finally, select pieces of this technology are excellent candidates to be taken cross-platform, and Apple will be exploring that and investigating that in the next year. Now, I mentioned platform for future themes. Some of the themes you'll see are 3D, digital photography, which includes image processing, and animation, which is a little different from QuickTime. I'm going to focus on 3D right now. We are building a 3D system on top of the 2D system. Today, in a high-end 3D application, what you do is you create a whole bunch of objects off in this 3D thing. You hit a draw button, and you wait an hour, 2 hours, a weekend. You get a picture. You're real happy. You take the picture over to something like Adobe Photoshop, and then you touch it up. You play with it as a bitmap. Because we're building a 3D system on top of a 2D system, we can maintain the mapping between the 3D objects and the 2D objects so that after you've rendered, if you've drawn this picture, you can come back and work in the 2D space and still manipulate the fundamental objects that you had in mind, and then only redraw those portions which need to be redrawn. So this will be a tremendous productivity improvement and enhancement to what we have today. The 3D architecture is open. Let's face it, Apple hasn't been way out in front on 3D, and there are a lot of great standards out there already. RenderMan, Silicon Graphics, some file formats. So we have an opportunity, and we're building in the ability to support those standards.